Hey, welcome back. We have already seen n8n's UI navigation and the n8n's core foundational building blocks. And now we are going to look into the very important aspects of n8n, which is the data structure. How those nodes can talk to each other, what is the input it can take, and how it produces the output. Let's get into it. When it comes to data structure, the two main things we need to understand are JSON and a list. So JSON is just a key value pair where any software program uses to transfer data between different components. So as you see here, so this is called JSON. So it has a key and a value. So that is what it has. So the open braces and close braces represent the close and start of a JSON. And then the list comes on the top here, the square brackets, whatever is there within the square brackets is a list. So it can contain more than one JSON within that list. And also it is nested JSON. So meaning a JSON value can be another JSON object also. Now let's get into n8n and see how the data is being structured. So I'm on the n8n dashboard right now. And then if I go to data tables, so first thing what I have done for this exercise, I created something called a table, a data table, which holds some data for us to, explain the concept of the data. So this is a shopping list. So here are the list of products which I have added for this demonstration. I open the new workflow and then I go here and select data table. And then I select get rows and then, so I'm going to get a row from a data table with the name of the data table is called shopping. And then match condition, I'm going to give the ID matches to or something like that. Okay. So when I execute this step, as you see here, this is what we talked about. So the output is a JSON basically, which is a list of JSON. So it is embedded inside a list, a JSON object. So this is one JSON object because we just get one row here. So this returns a row which ID equals to 2 with all the values of the table. So it is basically a list of JSON, but here in this case, it just returned only one item. So if I say get a row, and then if I delete this value and return all, when I execute this step, you can see here, it returns basically all the items in the table. So apple, spinach, milk, everything, all the 31 items in the table. That is a list of JSON objects. That is the list of JSON object we talked about. So this is how it generates the output, and it can be an input to another step also. So now if I go ahead and add a step called edit field. So I set this field, and then as you see here, so this becomes now the input for this step, and then output could be whatever we are going to do. So if I add a field and say the product name, and then the value here, I take this product and add it here. So as you see here, so every node has a default object called JSON, which is what it takes as an input. So all the input is stored in that JSON, and using that JSON object, you can directly call any property value you want to use in the node. So here I just put the JSON.product. As you see here, the value is called apple. So that is what it is giving. So if I execute this step, so what happens is it extracted all the values of the product and created another list again. It is a JSON list with a JSON in it, and then the key value pair is a product name and an apple. If I go here, if I say execute once and then execute this, it will just return the first product in the list, right? So that is what this is, just returning the product from this field. And since I said it is execute once, it doesn't execute. There are 31 items which returned from the previous step, but I'm saying only execute once. So that means it executed once for the first item. So that's why it returns this first product, but still it is in the same structure. So the input is a list of JSON array. the output is also a list of JSON array. So that is how it works. Now let's look into an important topic, which is transforming data, right? What are all the different possible ways we can transform the n8n data before we send it to another node, right? So the first thing, we are going to go here and then look at a separate section called data transformation. So that is the important area. So there we can see a lot of items. So we'll go one by one. So the first one is the filter. So this one, we will add it to this node. So I add a node called filter and then add it to this node. So and then open this node and then I say value equals to. So I took that code, value equals to. I want to filter all the values from this list where the product is Apple, right? So in this Apple. So if I say Apple and then execute this step, so now you can see there are 6 items executed and 25 items discarded. So this is the filter. So this is a nice way when you have a big list of items, if you want to filter anything based on any conditions or any date or array or whatever format it is, it's a very handy tool to filter out the data to get the clean data before we send it to the next step. So there is a good option here where you can say convert types where required. So in that case, if we needs to convert it into one type to another type, for example, if you have a date as a string and then convert it into a date, that all this automatically does that also, right? So that is filter step. So now we'll look into the next step, go to the data transformation and then limit. So we will add this to this main step and then go here. So limit. So this is like, okay, you have a huge gigantic data set, but if you want to limit to first or last few items, so this step can be very handy, right? So if you want to take the first 3 steps first or last, right? So that is all you can do with this step. So straight away, quickly take a first 3 steps and last 3 steps. This is just a simple, quick and easy way to filter out the first and last 3 steps of the step. And then now let's get into the next one, which is remove duplicates. Okay. So remove duplicates from the request. So now, as you see here, so this is our get rows table where we can see all the values, like 31 values. So now I wanted to remove the duplicates of all fields. Okay. So I'll say selected fields. Okay. Because the product is our main field here. So there are a lot of products which is apple, ice cream are all repeated here. So as you see here, apple is repeated, lemon is repeated, all these fields are repeated. So I want to remove the duplicates. So the easiest way to do it is I say product. Based on the product, remove all the duplicates. So as you see here, there are 31 items in the original list. If I remove the duplicates, I can see only 9 items. So those are all the only items on the list, but rest are all the duplicate of the same 9 items: apple, spinach, milk, ice cream, lemon, and stuff like that. Okay, so this is a very easy way to remove duplicates from the list of array. So next thing is split out. But I want to split this by the product, right? So if I say by the product, so I want to just extract, I don't want all these fields in this array, but I just want the product alone, right? So now if I say it returns all the 31 items, but only returns the product alone because I am reducing the noise from the data, right? So I don't want all this create date, update date, all are because if I want to send it to a large language model, it's all unnecessary noise if I'm not going to use any of this data value, right? So before we send it to a large language model, to reduce the data, I can split this big gigantic array into small meaningful array, which is only needed for our processing, right? So that is the split step. So the next one, let's see. So the next one in that list is aggregate. Okay. So aggregate is a very interesting step, right? So if I want to aggregate this array with a field, like for example, in this case, I'll take this product as a field. If I say aggregate, as it see here, it took all the product and bring it into one big list of product. Okay. I can rename the field also, like add a field to aggregate, rename this field as an output like products. because it's list of products, right? So if I say that, then it'll say the output field is a product. So these are all the products which I have aggregated into one simple list. Okay, so nothing else, just one simple list. So now it is even more simple and less token, which is easy for me to send it to an LLM, right? So that is the aggregate step. So the next step is the summarize step. So if I go back into data transformation and then go down and summarize. So summarize is an interesting step where we can summarize the data like average, minimum, max, count, all the stuffs, right? So here you can see you can aggregate it, concatenate it, maximum of, sum of, unique values, all these things. For now, so I'll go with just the count. I want to count all the apples, all the spinaches, or something like that, you know. So if I say count and group by or split by the product name value, then if I say that, as you see here, we have 6 apples, 6 spinach, and then there are 3 milk, 5 ice creams and stuff like that, you know. So that is the thing. And then the interesting part is if I go here and say um, append. Okay, so now what it is going to do is it's going to append all the values of the product. Okay, but I don't want the product to be appended, I want the ID. So for example, I want to all the IDs of apple, so that in the next step I want to process all the apples, right? So if I do that, as you see here, so this is the IDs. Okay, so 2, 8, 13, 19, 22, 28 are all apple, right? And then same way here, right? So this is a very, very easy step for us to aggregate the data or summarize the data and then move it to the next step, so that the next step can have a clear scope of which item needs to be filtered out, which items needs to be fetched, and then process it to the further values, right? So this is a very interesting step. Here we can append or get a maximum sum of all the IDs, which is not the right use case. But say for example, if there is a cost for this, you can do a sum of cost here, and then it will give you a cost total, right? So this is adding up the IDs, but assume if it is a cost value is there, and then we can put a cost field here, it will add all the cost for you, right? So Apple total cost, right? Something like that, you know. So that is this summarize step, okay? And then there is last one more important step as part of this data transformation, which is merge, right? So this merge step is a very interesting step as well, right? So if I go here, as you see here, every step has one input, but this merge step has 2 inputs. That means it takes 2 JSON objects and then merge that together into one object, right? So that's what this is going to do. So for example, in the limit, we took the last 3 items. So this is test, 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 test one, ice creams. So these 3 items. And then in the filter, we said only filter apple. Okay. So if I execute this, you see here 6 apples are there. So 6 items are there, 6 apples are there. Okay. So, but now I want to merge the 6 apples and the 3 last items together, right? How do I do it? So we don't need to write a code. We just put the 2 inputs here. And then if you execute this step, this will add this 3 test. So test one, test two ice creams, and then the 6 apples, apple 2, 13, 19, 22, all the JSONs of apple, right? So that's how the merge step will work. Now it is a single large list of the merged content. So basically, these are all the primary data transformation steps from a n8n perspective, as you see here. See, now we'll talk about another important concept of data transformation, which is the synthetic data, right? So if we don't have a data, if you want to generate a data manually for one step, how do we do that? And how do we save the data for next round of testing? Okay, so that is very interesting concept. Let's get into that. Okay, so if you look at this step, this get row steps, currently it is getting it from our data table, right? So these are all the table. But what if we don't want to fetch it from every time, and we want to use this as the same data for the future steps, right? So that is where the data pinning comes into play. So data pinning is, if I pin this data, it says this data is pinned for test execution. That's what it's saying. That means After that, I don't need to execute this step. Automatically, this data is pinned as an output. So it is available for the next steps for the testing round, right? That is what it means. So if I execute this step, it will not execute the previous step. That is what it does, right? So if I execute this, this step is only executing now. I don't see this step executed at all, right? So that is what will happen if you pin the data for the step. So this is a way you can save the data. It's kind of temporarily saving this data until you do a thorough end-to-end testing of the flow, and then you can remove the pin so that the data flows. This is only used for test execution at a node level, right? When we are executing at a node level, only at that time this is being effectively used. The another thing is editing this data, right? So for example, if I want to try an error handling situation where I don't want to expect to see Apple here, something else is coming. So in that case, how do I simulate that? So if I go here and edit that data and then say Apple 1234, right? And then save that data. Now it becomes Apple 1234. So if I go back to here and remove duplicates and execute the step, I see here Apple 1234 and Apple also, right? Because Apple 1234 is another one. So previously it used to be 9 item. Now it is 10 item. So this is how we simulate the data for all the test scenarios which we wanted to do as part of the workflow, right? So this is more about data creation for testing purposes and pinning the data. How do we use this data and manipulate it for the next subsequent test cases and stuff like that? Okay, so that is pinning the data. And then the last one, which is very important, which we have touched on the initial section of the video, which is the data tables, right? The data table is a very, very good concept where you can store data temporarily for any workflow execution or any kind of a small data. If the data is very less, there is a storage limit on this data table, how much it can support. But if the data is small and it is transient, so you can very well use this data table to store, retrieve data like a session related data and stuff like that easily can be managed through data table. It's like a simple database, right? So you can go ahead and create a table. So if I go here and then create a new data table, so I say this is like cars, okay. From the scratch, I create from the scratch, or I can import it from a CSV. So if I go here and then car name, okay, string, and then model, string, and then year, which is a number. Okay. So if I put that, so this is the data table, right? So now I can add a row here and then say name of the car, Tesla, model Y, and then year is 1990. I don't think 1990 Tesla was there, but let's see. Okay. So this is the row, a simple row I have added here. So I can keep adding a new row here, Honda, and then model is CRV, and then 2020, 200. Okay, whatever. Okay. So that's the two rows. So now we can go here to our data structure workflow and then connect that table and then use it for all the purposes, right? So as you see here, now the cars is being listed here. So if I select cars and then execute the data, it clearly tells me, oh, okay, testing on the node overwrites the pin data, right? So that means if I execute this node, then the testing data which we pinned in our last step will go away. So I said, okay, unpin and test. Okay. So now this is executed, and as you see here, it provides all the values from the data table, right? This is the easiest way to store, retrieve, manage data within n8n as very, very easy way. And it is part of the n8n platform itself. This is like something like a Airtable, right? Previously, Airtable is something very famous, which everybody uses for that. Airtable. This is the Airtable, which we need to connect to a third party and connect all the credentials and all. But now it is inbuilt part of n8n version 2 itself, right? So with that, what we can do is if I go and search data table, see here, I can delete row, get row. If row exists, I can do something. If row doesn't exist, what should I do? And then insert a row, update a row, upsert a row, right? All these activities can be executed as if it is a traditional relational database, So that's what this data table is. It's very, very powerful, and it's used for many use cases when we are building a workflow, right? So with that said, I think we have pretty much covered all the data aspects of n8n. So starting from how the structure looks like. So it's a simple JSON key value pair as a list always. And then every node has a default object called JSON. And then after that, we have also looked at different ways of transforming the data using the default nodes like aggregate, remove duplicates, limit, sort, split, summarize, and all that. Those are all the important nodes used predominantly in most scenarios for transforming the data from one format to another format. These transformation nodes are basic fundamental nodes which are easy to configure without any coding, right? But if there is a more complex need for transforming the data, then we need to use something called a code node where you take the data and transform the way you want it, okay, and then give it to the next step. But so with that said, it covers pretty much all the foundational building block of a data structure and the data related nodes, okay. Keep playing with it. We'll see you in our next video. Thank you. Bye.